Hello, it's time for video number 71 called Approximating Circles with Polygons. This is the last topic of this unit. We're almost done with this. So in class, we discussed this a little bit. The idea is to approximate the area of a circle with a polygon. This polygon right here has, let me see, 1, 2, 3, 4, 5, 6, 12 sides around here. So it's broken down into 12 triangles, but the polygon is formed by the edges. And it's almost equal to the circle. Down here in this one, we have kind of a orangish or tan kind of hexagon that approximates the circle. It's not so good, but the 12-sided polygon, the blue one, does a pretty good job. It's pretty close to the circle. Okay, so we want to find the difference between the area of the polygon and the area of the circle. That's kind of the idea. All right, here's a little demonstration of what we're up to. There's a gray circle here in the background. It actually has radius 1, and the circle's area is pi times 1 squared, which would be pi. So the gray circle back here has area 3.14. The area of the polygon is shown here. So we could start with a triangle. This triangle is not a very good approximation of the area because we see a lot of the circle kind of poking through here. There's a lot of gray we see here. But as we increase the number of sides to a square, to a pentagon, to a hexagon, gets to be a lot better approximation. But still, I see a lot of the circle here left. So as we increase the number of sides, it gets better and better. Here, the circle has the area 3.14. This blue polygon has area 2.89, getting pretty close. There's only a little circle left there. But as we have more and more sides, the polygon really starts looking like a circle. It's not quite a circle. You can kind of see the straight little pieces here. But it's getting very, very close to the circle area. All right, so here's an example of what we want to do with this. In this case, we're given an octagon divided up into 8 triangles. And we want to find the difference between the area of the circle and the area of the octagon. Okay, so let's do it. The octagon is actually the easy part. So let me get my pen working here. The hard part is the radius of the circle. Okay, so to find the area of the polygon, well, it's an octagon and it's broken up into 8 triangles. So we're going to do the 8 times the area of each triangle. So each triangle is going to be 1/2 the base times the height. The base of each triangle is 6.9. And the height of each triangle is 8.3. And all I have to do is multiply 8 times all of that. So if I enter it in my calculator, I get 229.08. That's the area of the octagon. Okay, find the radius of the circle. We have to use the Pythagorean theorem for this. The radius of the circle, r, is the hypotenuse of this right triangle here. Okay, kind of made things worse. But 8.3 is this leg. This leg right here is half of 6.9. So this entire side is 6.9. So this part we need right here is half of that, which is 3.45. Okay, so to find the radius of the circle, we're using a right triangle like this. The hypotenuse is r, this is 3.45, and this is 8.3. Okay, so we get 8.3 squared plus 3.45 squared equals r squared. So r squared equals, when you do this, about 81. And r is about 9. It's like 9.00 something. Okay, so, all right, so the radius of the circle is 9 from the center to the circle. All right, so now the area of the circle is easy part. Area equals pi times radius squared. So that's 81 pi, which gives us 254.47. Okay, so the area is circle's a little bit bigger. Yeah, so we expect the circle to have a bigger area. All right, so if we subtract them, we get the difference. 254.47, that's the circle, minus the polygon's area, which is a little bit smaller. And we get 25.39. That's the difference in their areas. Okay, time for you to do one. This time we're approximating with a pentagon. Pentagon is a little bit small, right? The circle has some area here that's left over. So we expect the pentagon's area to be smaller than the circle's area. Same thing, find the area of the polygon. Remember, this time it has 5 sides, 5 triangles. Find the radius of the circle using the Pythagorean theorem. Find the area of the circle and calculate the difference in the areas. Good luck.